Hello, welcome to the subject VLSI Design and Technology. I am Professor Meenakshi Pancha from Electronics and Telecommunication Department, Paratibai Yanma Mujhe College of Engineering, Vagoli, Pune. In a previous lecture, we are explaining about the K map. We have seen the functions of 2:2 and 2:3-bit K maps. So we have to see the 2:4-bit K map and some rules of K map. We have seen some of 3 rules among the 7 rules. We have to see once again. This K map will be helped to reduce the Boolean expression without using any theorem. And we can the Boolean expressions are then used for implementing the combinational circuits. So let's see the K map. Let's take a quick overview of the rules of K-map. The groups may not contain any zero. These K-map groups cannot contain any zero. See here, according to our truth table or excitation table, what we are doing, we are going to filling the number of ones into these K-maps, and these are the represents the values of the K-map, and these are the variable. This is a variable extension bar, and according to this, what we are doing, we are filling the number of ones into this K-map. After filling the number of ones, and the grouping of number ones will be takes place here. See, according to truth table, there is a 0 is also inside the truth table. There may be available, but while we are doing grouping, the 0 will not be considering. So only once we can consider for grouping purpose. So first rule is what is that? First rule, group cannot contain 0 here. And second, we can group 1, 2, 4, 8 or 2 raised to the power of n cells. Here can group number of 1 and 2 number of 1 together, 4 number of 1s together, right? 8 number of 1s together. So how we can decide that the group should be contains number of 1s, how many counts? 2 raised to the power of n. Here I am writing the power like this. Double star is nothing but 2 raised to the power of n here. So, for example, if here is 1, here is 1, here is 1. See, these are the number 1. We will assume these cells having the value number 1. Remaining cells having the number 0 here. So, in a previous class, in a previous lecture, we have seen when we should use 2:2, that is this K-map, and when we can use this K-map. This is a 8-cell K-map, and this is 4-cell K-map, and this 16-cell K-map. When we should use which one? We have seen in a last class or previous lecture. So in this lecture, simply we are looking about how we can group the number of ones. So we will group the number of ones with another number of ones of the neighbor cell. So the 0 should not include these groups. We can group of number 2 ones, and we can group like a number 4 cells. We can group 8 cells. If there is total number of 1 is there, we can group like 8 cells also. So how can decide the number of ones of the neighbor should be having 2 raised to the power of n ones. So this is the rule. Consider third one. Each group should be as large as possible. Each group should be large as possible. See here, if having this much number of 1, so what we are doing, we are just simply, there is a 1 in a neighbor. So I am considering this as a one group, this as a one group, and I am considering this as a single group. So this is not beneficial. We have to decide the group like that. It should be having more number of ones there. So that will gives the reduced or short Boolean expression. So we have to keep it in mind if there is a possibility to make a group of huge number of ones include in that group. So we can choose first that one. If there is no possible group, the other number of ones with this group, then we can consider this single also. But first we have to start making grouping from higher number of ones. After we will come for less number of ones. This is the one of the rule. This will help to reduce the expression. Each cell should contain the cell should contain one in a each cell should contain one must be group. So whichever cell which is having number of 1 in a cell, that should be grouped. We cannot leave the any single cell which is having one number. So we have to group each and every ones. Here, while grouping, if the number of ones in a opposite corners. So see here, I am considering this. If see here, so like this, how we can group? Because we are grouping only the neighboring cells only. So if the number of ones having this corner ones is having the corner cells having the number of ones, then that condition what we can do? So in that condition, what we do, there is another rules, what opposite grouping and corner grouping is allowed here in this opposite grouping. So this one we can group or corner. So we can group like this. We can consider these 4 corner and we can say these are grouped by 4 ones. So here in the K map, opposite grouping also allowed. Opposite and corner grouping is allowed. So let's see another rule. What is the rule? There should be as few groups as possible. There should be few groups as possible. While grouping, we have to keep it in mind. We have to select in a group more which is having more number of ones. So if there is a possibility, we can group number of 8 cell which is having one as a one group. We should consider first that. After that, we choose next, or we can see whatever the possibilities which is having more number of ones should be comes in a group. So after that, we have to keep it in mind there should be minimum number of group is there, because if we are considering the small groups and we are not and we are considering small group which is having single or two ones, it means the expression will become very lengthy. So there is no meaning of using this K-map. So the K-map is simply using for reducing the and simplifying the Boolean expression without using any loss. So, and after we can construct the combinational logic circuit using that expression. So this is the main use of this K-map. So that's purpose the K-map is using. So these laws we have to keep it in mind while doing the or simplifying the Boolean expression. Let's see one or two examples of the Boolean expression that it will help in solving the problems. Let's see one example. This is one expression. We have to simplify this expression. So we are considering this K-map for simplifying this expression. So we have to think first how much variable present in this expression. See here, A, B, C, D, B, C, D, all the in the full this line which there is a 4 variables A, B, C, D. So we have to choose 4 into 4 K-map, that is nothing but 4 power 2 raised to the power of 4 K-map, which is having total how much 16 cells. So we have to consider this one accordingly. Then we have to convert this expression in the form of zeros and ones, because what the value we are going to filling in a K-map, only 0 and 1. So we will consider whichever the variable having bar or cap inside cap on the letter, which is a complemented variable. So in this case, except in this case, what I am doing here, I am taking this symbol for identifying which is having a bar. So let's convert this expression into the zeros and ones. Here A bar is nothing but which is having value 0, B bar is nothing but 0, C bar is nothing but 0, and D is nothing but 1. And A bar is nothing but 0, B 1, C 1, D bar is nothing but 0. So we have to convert this variable in the expression into zeros and 1. Then accordingly we have to fill in the K-map. 0, 0. So after doing that, this is the variable separator. Here I am considering variable AB, AB, 2 variable in this side, and here C, D. So accordingly we have to give the number 0, 0, 0, 1, 1, 1. Remember here after 0, 1, there will be 1, 1 will be present there. We should not give 1, 0 there, because I have told in the previous lecture, every next step what we are doing, single step changing should be happen here. 0, 0, 0, 1. Here only one bit should be changed. So here 1, 1 is nothing but here already here 1 is here, then this 0 is changing from 0 to 1. So that's why we are taking 1, 1 here. If we take or we consider 1, 0 is nothing but suddenly at the next stage what will happen here, suddenly 2 bits are going to changing. So that's why we are not considering the 1, 0. We have to give now accordingly we have to fill the number of 1 present in this. See here 0, 0, AB having 0, 0 and CD is 1, 0. Where is in this row 1, 0. This row should contain number of 1. Then next 0, 1. 0, 1. Then AB having the value 0, 1 and CD having 1, 0. then this row, this cell should contain number of 1. The next A, B bar, or which having 1 0. So 1 0 this row, and C bar D 0 1. So this row which is should contain number of 1 and 1 1 0 0. So 1 1 0 0. So these are the number ones. These cell only should contain number of 1. So other cell we have to consider as 0. So according to truth table, if they are given truth table for us, we can fill like this only. This should not contain 9. It's only 0. There is no 9. Here we have filled the every cell of the K map. Now we have to start the operation of grouping. First law is the group may not contain 0. So what we are doing group, that group should not contain any 0. And the single group we can consider if there is a no any neighbor cell which is having number of ones. So we can consider this number 1 on a single group. But we have to first think about the what group should having a. Now we have to think the what are the possibilities of cells which is having for grouping with each other. Right? This is 0. So we have to start grouping. So this number 1 which is not having number 1 at the neighboring cell. So we cannot group. So we consider this as a single group. So we considered as a single group. So what is the value of this? So this AB having AB, C bar, D bar. This having AB, C bar, D bar. And this we can make the group of which is number of ones having at the corner or at the edge. So this and this we can consider as in a group. So see the what are the number here there 1 0 and 0 1. So 1 0 we have to choose. So 1 0 and 0 1. Which one is same in a both? So we have to choose first one. So we consider this column, sorry, this row and this row first, because these two row, the number of ones we are going considering here. So this row having the value 0 0 and this row having value 1 0. So we should consider the common thing in both the value. Here 0 0 0 0 is a common. So we have to take the this value B and bar because it's having the value B here. So the column is common for both. So we can choose whatever the value here, that only. So that is C bar and D. Then we have to add. Then there is no neighboring cell which is having the value 1. So I am grouping here only single cell, single number of 1 as a group. So simply considering the number, which row is that? That is AB and C, D bar. This is the simplified expression for that game. So let's see another example. Let's see the another expression. So we are assuming here expression is not given. Here they are given a K-map. So using this K-map, we have to construct the expression for this K-map. This K-map having the value of number 1 here. So simply consider these cell having number of 1. So this is the K-map they have given. So using this, we have to simplify the and write a Boolean expression. And first consider grouping, which is having number of ones. First we have to consider the number of ones. The grouping should be contain the value 1, 2, 4, 8, like this. The grouping value should be contained like this. So first here we can consider this as a group, which is having 8 number of ones. Which is having 8 number of ones. Second, we can consider these group, which is having 4 number of ones. And this as a one group. Remember that if group is formed, if there is a number of 1 is here, so we can consider these two as a group. Again, if this cell is engaged with this group, then can be then also we can configure with or can consider in a group with other cell. So let's simplify the number of groups. Here this group here this group so here in this group what will happen? There are two rows. We only consider these two rows. If we have grouped like this, then we can consider only these two columns. So the minimum possibilities we should consider here. So let's see, these two rows are grouped each other. So we cannot consider the common characteristic. So sorry, we can consider the common characteristic here. So the value A, which is having high and high, both the rows having common value A. So this group gives the value A. This group gives the value A, and let's see if this group what the value will be give here. So here both the row, these two rows are grouped here. So what is the common value in these two group is A bar. So this group gives A bar, and these two groups are engaged here. So let's see which one is common characteristic in this group. The letter C. The C having high signal on the both the columns. So we will consider C. Then fine. So this group gives the A and these groups gives A bar C. Then what about this? So this is the single. So we can group with this cell. These two are common. So how we can see which is having this row and this row? What is the common characteristic of these two rows? Which is having value 0. That is A bar and C bar, D bar. So this is the simplified expression. How we can write the expression? We can write all the A bar, C bar, D bar plus A bar C and A. This is the simplified expression. So using this, we can design combinational logic circuit. Also, these two having A, B, C, D, we can design AND gate here. We can design AND gate which is having 3 input terminal A bar, which is having V bar, C bar and D bar. Like this we can design. So these are combined with the OR gate. And another AND gate will be used here. This AND gate should consist what the value A bar. So this is the A bar we can connect and C. So this is C behind the inverter we can consider like this. And another A bar. The another AND gate which is having single input, that is A bar. So like this we can. So this is the way of designing the combinational circuit here. So the next we will see about state diagram. So what are the state diagrams and how we can draw the state diagram. So let's see what is the state diagram. A state diagram which allows the behavior of state machine to be analyzed rapidly. In addition, the state diagram can be quite useful in designing a machine from a set of the specification. The circular state symbol contains the name of the state with the state code adjacent to the symbol. So simply we can say that it is a pictorial representation of a behavior of sequential circuit. So we can represent it. So let's see how to construct the state diagram for D flip-flop. So for state diagram, we required the excitation table. So this is the excitation table. We have explained how we can write this table. Q n plus 1 and this is E is an input. The excitation table specifies to require this present state and present output at the terminal. The what should input we have to provide. So we have to provide 0 for getting this state at the present and output state. So 1. So this is the excitation table, how we can written. I have explained in a previous lecture. So present state is 1 and the present output is 1 is nothing but what input we have to give? We have to give the input 1. So using this we have to draw the state table. So there is a two state, that is 0 and 1. State 0 and state 1. State 0 state 1. So first see the excitation table. What will happen here? See, here the state changing from 0 to 1. So, and getting 0. So here state changing from state 0 to state 0 remains, it will state 0 when we are giving what input? 0 as a input. And what we are getting output is also 0. And here also state changing from 0 to 1. So 0 state to 1 state it will going to changing, and at the what input? At the input 1. Similarly, the state 1 to 0. So similarly, state 1 to 0 will be changing. And what are the input? Input is high. Should be 0. This should be 0. Then state 1 to 1. Here state 1 to 1. So at what input? At D is 1. Then this is the state diagram for D flip-flop. So let's see how we can construct the state diagram for SR and JK flip-flop also. Here this in a circular form we can shows the state, we can represent state, and this triangular form is nothing but it will shows the this diamond form which will shows the inputs, and these are the conditions, and this is the output shows in a rectangular form. So we will see how we can utilize this. Before that we have to see how we can construct the state diagram for the flip-flops. So let's see now the SR flip-flop excitation table for SR flip-flop. So which is having two input. One is, so this we have to first consider Qn plus 1 S R. So if Q is 0, Q1 is 0, then what input should be give? 0, and X is nothing but undetermined. When this one is 0, this one is 1, then what we have to provide? S should be 1 and R should be 0. Then the present state is 1 and the output is 0. Then what we have to do? We have to provide S should be reset condition and R should be 1. When both states are high, then what is the state should be undetermined and R should be 0. This is the excitation table for SR flip-flop. So there are so we have to draw the state diagram for SR flip-flop. There are two states. Yeah. There are two states. So first we will consider the state 0. Next we have to consider 1. What is happening here? See, the state is changing from 0 to 0. The state is changing from 0 to 0. What of the combination input? The S should be 0 and R should be undetermined. This input combination provide the same state. There is no change from present state to next output. Okay. Then from 0 to high. Let's see 0 to high. What combination should we give? 0 to high. Then we have to provide S should be 1 and R should be 0. For the state 1 to 0, for the state 1 to 0, what input should be provided? Yes, it should be in reset condition and R should be 1. So for state 1 to 1, what should be give? S should be undetermined and R should be 0. So how to write this excitation table I have explained in the previous lecture. Please listen there. So now see the excitation table for JK flip-flop. For JK flip-flop excitation table. So which is having present state input and next state output, and there are two inputs J and K, and this is the combination of the input 0 0. At 0 0, what should be the input we have to provide? J compulsory should be 0 and K is undetermined. Both are 0, then J should be high and this is undetermined. 1 0, so this should be high. Sorry, this should be undetermined and this is high, and both are 1 1. So this should be high, this should be 0. So this is the excitation table for JK flip-flop. So let's see. This is state 0, this is state 1. So here state 0 to 0, what is happening here? State 0 to 0, there is J should be 0 and K is undetermined. And the next state here 0 to 1, 0 to 1. So what should J should be 1 and K is undetermined. And state 1 to 0, state 1 to 0, 1 0 combination should be input, and state 1 to 1, this is 1 to 1. So this is combination input we have to provide. So this is the state diagram of the JK flip-flop. So we have considered here single variable. We can consider multiple variable also. Let's see. So today this is enough. So in the next lecture we will see how to simplify the simplify the circuit diagram, and we can draw the state diagram for that circuit diagrams. So few examples are there. We will see in the next lecture. After that, we will go to the topic introduction of metastability. So this is enough for the day. Thank you.